So just iteration.
Excuse me.
Yeah. Yeah. Five. We have to go for 509,
509. Yeah.
which gives us a belt length of 2100.
Yeah.
Yes.
The gear
And
ratio.
this,
Sorry.
sorry, the
Okay.
is 34, 44,
Thirty-
and the D
34, sorry.
yeah, is 192.
Yeah.
Just while we're here, I noticed that if we took the speed ratio 2.5,
2.5.
we have
Mhm.
much more. We have
Three.
a possible centre distance of 542,
Okay.
which
Yes.
to my mind would be a sensible thing to look
More
at.
Okay.
suitable one.
This one, sorry.
Yeah, yeah, this one.
Mhm.
Yeah.
So the
Okay, should we?
So I think we
yeah,
might.
Should we
just
try
yeah,
this one?
try this
Yeah.
one. Yeah.
Okay, so it's 32 groove 80.
Yeah, sorry. The R is 82.
The
N
N
is 80. Yeah.
Okay, belt length 1890. Yeah. Okay.
Yeah.
And the center distance 542.
Yeah.
Okay.
Okay.
Right.
Okay,
So
we
when-
have this one.
We need to go and check out the power
Yes.
now.
The power was.
Yeah.
Okay, so we have the first bring of the plaster shaft, we've got the B50, 16 and 1600,
Okay.
and we have,
Let me just give you something.
we
Groove was how much? Was it
Yeah, it's 32. 32.
32.
32.
Oh, so we exceeded massively.
And,
We have a power of 44, in turbos between 44 and 47,
Oh,
so
that's a lot.
this is also quite over-engineered.
This will be a lot more range.
Can we have a look at, what was the power that we came to from the previous, the 8MGT, taking the width as being 50 millimetres?
That was the
Is that the,
34, I
that seems
Yeah,
much more
That's mine is
sensible.
34.
think.
Yeah.
Yeah.
That's my 34.
No,
And
the power for the 8MGT one we got. Yeah. Okay. 36.
36.
36, whereas when we look at this one we have a power of around about 40, oh, sorry, which,
Six.
32 teeth or 34 teeth we look at?
32.
32, we have 44,
Oh.
what's between 44 and 47, so say 45 in turbo, that's much too
A
much.
lot higher than
That's,
the one
that's double,
Mm.
we don't need that much. So if we say, we checked out the 14 MGT,
Mm.
it's a bit, it's excessive for our purposes. I mean, of course, we could do the 33, the 3.3 to what the
Yeah,
is checking.
3.3 is good. Even higher.
What how many teeth does it
It
have?
was 34.
No, it's,
Oh, both the
oh,
pulleys
this-
larger.
this
Yeah, it uses like
34, yeah.
two large pulleys.
yeah.
I think the most sensible one at the moment is the 8MGT, taking the 50mm wide prop.
Yeah,
Are we happy with that?
I am happy with that. Okay.
And that was a speed ratio of 2.5, is that correct?
2.5, yeah.
That
Okay,
was, yes.
so now, if we've chosen that, now we need to choose the belt that goes from the shaft to the pump,
Yes.
the pulley
And we need
arrangement.
1 to 4.
1 to 4. So the 14 MGT, we don't actually, we're not interested in that at all.
Try the 8MGT one. Start again. don't we?
Just start again. Well, the design power doesn't change, does it? Or the service factors, they don't change.
No.
Yeah, so
Um,
that's it.
What we have is different speeds, so we have 1 to 2.5, so our shaft is, instead of going, pump's going 1500. The motor, sorry, is
Yeah,
going
the motor
1500.
1500 reduced by 2.5.
So it's 600, isn't it? We drop to.
600.
So we have
So the
600.
faster shaft is 600.
Yeah, I mean, that takes us across. It's still putting out quite a bit. We may actually need the bigger belt for this, because it's putting out, it's a higher torque going through it.
What was
Tension.
the design?
Design power was 22.5 kilowatts, wasn't it?
So,
Yeah.
Oh, we're still in the 8MGT, so we're fine.
Yeah,
Okay, so I'm going to go into the 8MGT. Right. Centre distance tables. Okay, can we have a quick look? What was the difference? It was also between, so it's 550 the distance between both the pump and the motor. The centre distance is exactly the same. Okay.
Okay.
So we want a speed ratio of 4. Okay. Okay, sorry, we were looking at centre distances.
For
So
the
speed
pump.
ratios, we're choosing for the pump now. So we've got a speed ratio of 4, Okay.
Yes.
Now, do we have
So these are the papers,
charts
yeah.
for? We're looking at still the 8
And
GT series of
yes.
belts. Okay.
So,
Right. So what do we have here? Speed ratio 4 doesn't take large enough. That was at page 72. So page 73. We have a speed ratio of 4, and we have centre distances. We have a choice of 521, 501, 508, 590. I think 521 is closest to what we're after. Okay, so for that one we have pulleys 144 for drive N, 36 for drive R, and a belt length code, basically length of 1800 millimetres. Okay, now check what
This is the
that
power.
happens on the power. Do you need that? Sorry. So we have front shaft at 600, and we said we had a pulley of 36. So we have 42. Okay, so we need to get up to 22. If we take the belt width of 85, can you multiply that by 4.75 is the factor? 25. We're fine. Excellent.
Yes.
So we're fine.
Yes.
Okay, so it's 85 millimetre width belt there, which gives which is fine. So we have the width factor of 4.75
Yes.
to multiply the power we can transfer.
Yes.
Okay, so we have our
Our transmission
is all
system.
selected. Yeah. Now what we want to do is work out. We select our components. Okay. What we have to do. Well, we select the transmission pulleys. We need to select the bearings. Well, we need to work out what the bending
Forces.
forces are. Okay, so we'll start again.
Start again with calculation. Motor.
So what we need to do is we need to work out, this stage now is we're working out the bending moments of the shaft, so we can select bearings. We need to know what forces act on the shaft, which essentially comes through the belts. So we need to work out what are the tensions in the belt, in each belt, which we work out from considering the power and also the direction that they act in terms of vertically and horizontally, depends upon pulley diameters. So if we look at the motor, the pulley from the motor to the shaft, we have, what are the sizes did we say?
The size, yeah.
Sorry, the
For
size.
the motor.
Transmission.
Okay, just refer to our notes.
I draw that diagram here.
Yeah.
We also need to make an assumption that the contact point of the belt and the pulley is
Okay.
at the very top of that.
Okay. Yeah. So not at the tangent.
Not at the tangent point, because the angle is very small. We can look
Yeah.
at that.
Yeah. How are we doing there? So it's a paper chase, isn't it?
Yes.
This is the
I think with the motor, we did that quite early on.
yeah.
6, 5,
5, 4.
No, this is
No,
for
this is
373.
5.
Yeah. Page 4, I think.
4. Yeah, here, yes.
That looks it, yeah.
Yes.
So we
Okay.
have,
So
So we have
distance.
36 tooth on the smaller.
yeah, so 36 times a pitch of 8 gives
8.
us, shall I do this?
Gives us the circumference, right?
Yeah, so the circumference of 28, so divided by
Pi.
pi will give us a diameter, pi, 91.7.
91.7.
Yeah.
Okay.
And now if we take the large one, so 90t, so 90 multiplied by 8, once again divided by pi, gives us 229.2. So the 29.2. So if we subtract, that's for the larger pulley. So diameter of subtracting the diameter of the smaller pulley gives us, so divide that by 2 as well, gives us a difference of 68.7.
68.7 on the.
Different, yeah, essentially the horizontal, the vertical.
Oh,
And the
sorry, that's
It's
the
the
difference. Yeah.
Yeah.
Okay.
So if we're trying to work out the angle, so
this
that's the opposite
yeah,
face is
okay.
68.7,
and we need the angle.
and the adjacent is